Hello guys, this is Samadhi here. Today we'll be looking at the transportation models, which is one of the modules, Module C, from the 12th edition of Operations Management by Heiser, Render, and Munson. There are three basic concepts that are introduced in this. First of all, the transportation model helps us. It's one of the special cases of linear programming. It is very helpful in allocating and balancing the demand versus supply, be it in marketing or be it in supply chain or specifically in logistics. We did in look at the transportation matrix, which was introduced in the previous module that we went through, especially in terms of reliability. Now, this is a typical case wherein in the matrix we look at the table. In the old days, they used to have cost right in the corner, and then they used to allocate demand such that by norm they would have supply on the rows and the demand on the columns. Yeah, so this is the demand. Let me make it a little bigger. Okay, so yeah, so this is where they would write supply, or also called as destination. Destination right here, and then this is also called as from or origin. Okay, so if you look at here, this is the total demand at any given point, and for every origin you have a supply. Yeah, so if you go by the linear programming, this becomes I to j's. Okay, therefore whatever you would allocate going from, in this case, Des Moines to Albuquerque, you would call that xij format, wherein if you were to give this any number, let's say you would call this 1, 2, 3, and name this as 4, 5, 6, then this can be represented as x14. Yeah, so x14, the amount going from 1 to 4, then x15, x16, and similarly you would have x24, x25, x26, and then you will have x34, x35, and then x36. Yeah, now that we know how to read the table, or how we are going to use it in future, there are three basic methodologies that are introduced in this module. The first one being the northwest corner method. Northwest corner method. The second one is lowest cost intuitive method, and the third one is stepping stone. Instead of stepping stone, I want you guys to use the skills that you learned from linear programming. The stepping stone is a repetitive process that helps you find the optimal solution. These two methods help you find one of the feasible solution. It may not be the best, but at least it will help you allocate such that all the demands are matched with all the supplies. And linear programming is a better approach moving forward, especially for you guys in the future, when you can replicate this or use this linear programming to find the optimal solution. Okay, these two help you find feasible solution, which may not always be optimal. Okay, feasible solution. Now, the objective in all of these problems is always to send the product from the origins to destination with the lowest cost. Yeah, so for example, in this case, if you had the choice to go by the USPS, okay, or UPS or FedEx, or let's say DHL, then we want to send our product in a form such that everybody gets what they've demanded without exceeding what any origin can supply. Okay, in many cases you might be able to stretch some of these things or influence some of these flows by offering discounts or promotions and stuff like that. But in the short term, on a day-to-day basis, the operations manager has to match the supply with the demand. So mathematically, your objective function becomes x14 plus x15 plus x16 plus x24 plus x25 plus x26 plus x34 plus x35 plus x36. Now these are all the coefficients. Correspondingly, now we bring in all the cost. 5, let me bring in red. So 5 x14, 4 x15, 3 x16, 8 x24. Yeah, so these are all the costs. Yeah, 4 x25, and then 3 x26, and then 9 x34, 7 times x35, and 5 times. So this would be the full objective function. Okay. Now, in ideal world, our objective would be to minimize this objective function. This is what we'll do in linear programming. Okay. Now, since not every time it is possible to do the linear programming, mostly if you are on the field already running with only nothing but a notepad, in those cases these northwest corner methods and lowest cost method are feasible or more useful compared to linear programming. Also, sometimes you can run the linear programming all you want, but many times on the fly it may not always be possible to design the linear programming and then run the analysis. Okay, so these two are very handy if you know the concepts to balance the supply and the demand such that everybody has something. Now, if we were to go by the linear programming, some of the constraints would be, let's say if I was to write subject to constraints, I will repeat these 3 numbers such that this has to be equals to or less than equals to 100. Now this is, I'm using less than equals to because we have not added a dummy variable yet. If you were to add dummy variable, you will equate it, and so instead of less than equals to, you will say it all has to equals to 100, because this origin 1 in this case Des Moines cannot supply more than 100. So whatever is sent to Albuquerque, Boston, or Cleveland from Des Moines has to add up to 100, no more than 100. Anything that we send from Evansville to Albuquerque, Boston, and Cleveland, which is anywhere in here, so starting from here to here, has to stay less than equals to 300. So that's your second constraint. Also, anything that is sent from Fort Lauderdale to Albuquerque, Boston, Cleveland, which is right here, has to stay less than equals to 300. Also, the demand for Albuquerque has to be met, which means let me see what other options I have here. Color, oh, I have green. So let's say the summation of all these, which is this one, and this one, has to stay less than 300. Similarly, what other colors do I have? Yellow, maybe? All of these, yes, there is yellow. All of these, which is this, plus this, plus this. Where in words you would say anything going to Boston from Des Moines or Evansville or from Fort Lauderdale has to equals to, sorry, my bad, equals to 200. Same thing for this one. I made a mistake here. This has to equals to 300. This has to equals to 200. The reason being, if you say demand everything that is demanded at Boston, either from Des Moines, Evansville, or Fort Lauderdale, if you were to say less than equals to 200, then it could be 0. So nothing would be sent, because mathematically that equation will hold true. So we have to meet the demand. Okay. Similarly for Cleveland, let me see if I have any other colors. Okay, apparently I do. Let's see what magenta is. Oh, okay. So anything sent to Cleveland has to add up to 200. So this, and this. This is anything being sent from Des Moines to Cleveland. This is everything sent to from Evansville to Cleveland. This is everything sent from Fort Lauderdale to Cleveland. All of these have to equate to 200 in order to satisfy the demand. Okay, as long as all these things happen, nobody should be able to complain, except for the business who is in charge of allocating this. They might be incurring different costs. But the first thing is to allocate the supply to match the demand. Okay. The next step would be to do it at the lowest cost possible. Okay, and we will slowly move on towards that target, going from northwest corner method to lowest cost method, and then the linear programming. Okay, now all that being said, the northwest corner method, so currently we are doing, let's say, red, northwest corner method. What it says is, if you were to design this template in general direction is north, south, west, east, then we always go for the northwest corner first in order to allocate our supply. Okay, so in this case, for example, the first thing you have to do is the northwest corner is this cell. Okay, now given the supply for Des Moines, you have 100 units. How much is demanded? Demanded is 300. So we can allocate maximum possible here. So 100 is the capacity. I'm going to allocate 100 units here. Now, the moment I do that, the leftover demand that is unmet is 200. In the spreadsheet, I would always recommend that you create a different cell, which is 300 minus sum of everything in the column, such that this gives you a live information as to how, the moment you punch in number here, this gives you information as to how much is the demand that is left over. Now, by as per the method of Northwest, since you've exhausted all of this supply, we will cross this row out. This is mostly to do to avoid any confusion. Okay, now we have leftover cells this much. Okay, within this much, the northwest most corner is this one, correct? So northwest. So out of all these 6 cells, this is the northwest most. Okay, in this case, the supply is 300. The leftover demand is 200. So we are going to allocate maximum possible here. Okay, the moment we do 200, we have a leftover of 0. Now, since this is 0, we are going to cross this column. Okay, in this case, there's only one cell, so we are going to cross this. Similarly, to avoid confusion, we've already crossed the last row. Now, when we used up 200 here, we have a balance of 100 left as a supply. Okay, now we have the next leftover set of cells as this one. Okay, within these 4 cells, the northwest most is this one. Okay, so we are going to allocate the maximum possible in this cell. Now, the demand in this case at the Boston is 200, but the supply left over from Evansville is only 100. So that is the best we can do so far. The moment we do 100, the leftover is 0, we cross over this one. Okay, now the out of the leftover cells, these are the 2 cells that we are looking at. Okay, in this northwestmost is this cell. Okay, so for this particular cell, oh, and I did see, that's why it's better to do in spreadsheet, but I'm just explaining it to you. When we allocated 100 here the balance is 100. Okay, so the demand that is yet to be met at Boston, we've already met 100 of it, is 100. The supply is 300, so we have extra supply, but the best we have to do is 100. We cannot overfeed somebody. So at the moment we allocate 100 here, you will have 200 left over. Okay, out of this we come back to the next cell, which is this one here, is the only leftover. So northwest, this is the only one left. So out of this, 200 is demanded, 200 is capable of being supplied, so we allocate 200 here. Okay, now in this case we were lucky wherein all the supply was equals to all that was demanded. Okay, now this may not always be the case, correct? So in this case 300, 300, 100, 700 was the capacity. In this case the demand was 300, 200, 200, which is again 700. If the supply and demand is not equal, we have to create what they call as dummy variable. Okay, now I always recommend that you always make a dummy supply and dummy demand variables, and I'll show that to you in a minute in the spreadsheet. But while doing so, we have certainly, this may not be the best possible allocation. You might be able to send more, let's say to the Boston by, instead of Evansville, you may be able to send it by Des Moines, and the total cost of allocation might be minimized. But at least this method allows you to match all the supply with at least some type of demand, or vice versa, that all the demand is met by some type of supply. In this case, the cost of allocation would be blue. So 5 times 100, yeah, plus we did not use these, so I mean, but theoretically it would be 4 times 0 plus 3 times 0, but then you would have 8 times 200 plus 4 times 100 plus 0 plus 0 plus 7 times 100 plus 5 times 200. Yeah, so these costs reflect these, and then the x variable, the xij, is the variable that we just allocated. So in this case it's 100, then 0, 0. In this case it's 200, 200, 100, 100, and then 0, multiplied 0, 0, and then 100 goes here, 200 times 5, 200 times 5. Yeah, so this is the resulting cost. Now at this point we are not concerned about the total cost. At least we are able to find a solution. Okay, now the next one is the lowest cost method. In the lowest cost method, we are trying to minimize, we are trying to find the cheapest transportation cost. So again, coming back to USPS, UPS, or FedEx, or DHL. Now try to picturize this. If you have the option to send something cheap in the cheapest cost by USPS, then why not use it to the maximum possible, such that you exhaust all your resources before moving on to any costly. Now I'm not implying that any of these companies are costlier than USPS, but I'm just giving you an example. Okay, so in this case, first we find out the lowest cost that is available. Now in this case, there are two options that are lowest cost of $3 compared to anybody else. Okay, now in this case, if there's a tie, you choose anyone. In this case, let me choose this top one. Okay, so sending from Des Moines to Cleveland, I'm going to allocate as much as possible here. So in this case, the best I can do is send 100 units to Cleveland. The moment I do that, I still have a leftover of 100. Once I'm done with this, then the next best cost is this one. Okay, so at this point, I have 100 demand. I have a supply of 300. By the way, this is all zero, so I'm going to cross these. This is just to avoid confusion, yeah, because there is no more supply left from Des Moines, so the Des Moines cannot serve Albuquerque or Boston anymore. Okay, now for this particular cost of next lowest cost is $3. I have unmet demand of 100. I have supply of 300, so I'm going to allocate 100 here because that is all that is needed. So it becomes 0. I will cross this one out because there is nothing demanded from Cleveland, even if the Fort Lauderdale was able to supply. And I have a leftover supply of 200 for this row. Okay. Now let's look at what are the leftover cells. The leftover cells are these 4 cells. Yeah. Oops. These 4 cells. So out of these 4 cells, the lowest cost is at $4 going from Evansville to Boston. So again, we'll try to allocate as much as possible. The supply is 200, the demand is 200, so we got lucky here. Everything matches, 0 left here, and since the demand has been fulfilled, we will cross out this one as well. Okay, now out of these two, the cheaper one is $8. Oh, sorry. See, since we have a supply of 0, we should have crossed it in the beginning. So then we would need not have considered this cell. Okay, coming back to the next leftover is this cell itself. Therefore, the supply is 300, demand is 300. We allocate 300. Okay, so 0 left over here, 0 left over here. So if you were to write the cost in this case, it would be here, there's more space, 5 times 0 plus 4 times 0 plus 3 times 100. Yeah, this 100 is coming from here. Okay, and then similarly 0 plus 4 times 200 plus 3 times 100 plus 9 times 300 plus 0 plus 0. Okay, so again, this allows you to match all the demands with the given supplies. Now, the last one would be the linear programming. Okay, one thing I wanted to highlight is that in the spreadsheet, you would have all of these cost matrix in one table. Okay, and we will try to allocate these coefficients in a separate second table, and then you can use sum product, something that we've been using all along in this course. I think this would be 11th or 12th time that we are using in any given chapter. Okay, so let's look at some of the processes, some of the end of the chapter problem to give you a hands-on learning. Okay, so this is one of the questions when they've asked us to use northwest corner method. Now, theoretically, this question would say stepping stone method, but I've changed it to linear programming method. Okay, so anything on this end is the given information, except that I've also created a dummy demand and dummy variable. Okay, and I'll show you why. First of all, this is all the cost matrix. These are all the costs that initially were given to us only in the top right corners. Okay, so that is represented in here. Then I've created a corresponding table, okay, such that we have all the supply points as XYZ. I have the supply points XYZ. Then I created a dummy supply point, okay, I have dummy supply point, and I have a dummy demand as well. Now, the reason I would suggest that you always make this is that it is better to create it now before you are halfway through solving the problem, and then you realize that your demand and supplies are not equal, and now you need to create one. Okay, so it's always a good habit to create a dummy demand and dummy supply, and you can always mark the costs as 0, so it will not affect, except it helps us balance the total demand equals to total supply, such that these methods of Northwest and intuitive lowest cost approach allow us to match the demand with the supply. Okay, that's the whole point. Now, let's see how we can start solving this problem using the Northwest corner approach. So using the Northwest corner approach, or I've already written this, Northwest corner approach, let's start with the northwestmost cell, which is this cell. Okay, currently the demand is 50, supply is 100. Okay, so the best I can do here is 50. The moment I do this, I will have a balance of 0 here, and I should have a balance of 50 here, out of 100 that was originally there. And the moment I do that, I should cross all these cells, okay, because it's not to be messed with, because the demand at point A has been fulfilled. Now, out of the leftover cells, which is these, this is my northwestmost method corner cell. So I'm going to allocate 50 here of the 80 demanded. 50 here of the 80 demanded. So I have a balance of 30 here, and this cell should become 0 here. Okay. The moment I exhaust 0, I can cross this row out, and I have a new area of cell, which is these. Okay. Therefore, the northwestmost cell being this one, wherein the demand is 30, supply is 50. I put 30 here. This becomes 0, and this becomes 20. Okay, and I can cross these cells out because the demand is fully met. Now, of this new 4 cells left, or 6 cells left, this is the northwestmost. Demanded is 70. Okay, supply is 20. So the best I can do here is 20. Okay, going from Y to C, this cell becomes 0, and this cell should reflect 50 now. Okay, and then we are looking at this one, this one, this one, and this one. So of this is the northwestmost cell, going from Z. Available supply is 75, demanded is 50, so we will put 50 only, and this becomes 0. We will not consider this cell, and we've used 50, so we should it should be reflected 25 here. And of the leftovers, this is the northwestmost cell. Okay, then we allocate 25 here, and we will say that there's a dummy demand of 25, such that this leftover supply is also used, and we get a 0. Okay, now let's see how we will do this in a spreadsheet. This is just to repeat what I was showing you on the lecture notes. So let us first allocate 50 here. Now the moment I allocate 50, don't need decimals here. Okay, the moment I use 50, I want some of the cells to reflect how much my left equals to this minus sum of at the top. Okay, now this tells me that there's no balance. Okay, let me name this balance remaining. Okay, similarly over here, remaining. Okay, which would be equals to this minus sum of all these. Okay, So the moment I allocate anything, it should tell me what more do I need to do. Now, also at this point, if you were to do total of supply equals to sum of all the supplies and all the demands, we know that there's a surplus of supply. So to make it balance, we should put in 25 here. Now we know the supply equals to demand. This method should help us find one of the feasible solutions. And in this cell, I have done sum product of all the costs. Make sure you're selecting the right dimensions of the first array times the second array. Okay, so it should be 4 by 4 the first one and the 4 by 4 the second one. Okay, so same dimensions. So at this point, by allocating 50 here, I have my total cost is 500 so far, but that's not we are concerned about right now. We are concerned about allocating and matching the supply with the demand. So now, since I've exhausted all of these cells, so theoretically, instead of crossing in here, I suggest you either color them differently so then you know there's no confusion about it. Okay, so these are the cells we don't need to consider about. Of the leftover cells, this is the northwestmost, so we have a balance, we have a demand of 80, we have a remaining balance for the supply of 50, so the best we can do is 50. The moment I see 0 here, I can color these cells off so I'm not confused, and out of these cells I have a balance demand of 30. My supply is 50, so I can use 30 here. Okay, the moment I see 0 here, I can color these two cells off. Of these leftover blue cells, the supply is 20, demanded is 70, so the best I can do is 20 here. Therefore, this goes off as black. And then of the colored leftover blue cells, this is the cell we are concerned about. Demand is leftover 50, supply is 75, so I put in 50 here. The moment I see 0 here, I'm going to color this cell as black. Of these two leftover cells, this is the northwestmost. Okay, so we did create this dummy demand point, and we do have the balance left over 25. So all of the supply is utilized, all these cells are 0, all of these dummy balance remainings are also 0. So at this point, our cost of transportation of sending 50 units from X to A, 50 units from X to B, 30 units from Y to B, 20 units from Y to C, 50 units from Z to C, and 25 units going from Z to a hypothetical demand point, which could be its own backyard of the Z itself, with a cost of 0. Okay, and all of these 50, 50, 30, 30, 50 are going at the cost of $10 a unit, $80 a unit, $13 a unit, and $19 a unit, and $9 a unit and $14 a unit. Okay, so the total cost we end up is $2,670. Okay, now everything else being the same, I'm going to copy this and paste it again and try this with the lowest cost method. Okay, now when it comes to the lowest cost, since we want to find out what is the lowest cost of all the given costs that are there, so let's say instead of me manually trying to check all the cost and which one is the lowest one, it is sometimes helpful, sometimes, not all the time, sometimes it's too much work, it's effort versus rewards, right? That I create a ranking table. How can you create rankings? Okay, let me show you. So if I was to say that I want to create ranking of all of these costs, okay, let me bring it in the view. I can say rank equals to rank this number in the range of this. Okay, now if I was to do this, it'll give me the rank within the given costs. If you select all of these, it will give 0 as the number one rank. Okay, so let me try this one, and I'm going to freeze this so that I can copy this formula around, wherein only, let me show you, only this cell would keep changing, but this range will stay fixed. Okay, and I want to do this in a descending or ascending order. Okay, so let me try, see what happens here. Okay, my test would be the 0 costs should have a rank of 1. Okay, so I should have tried 1 then here. Okay, I try 1, copy, control shift, arrows, done. Okay, so now I know what is the first number that I should be trying. Okay, let me check if it's working correctly. Okay, yes, yes, okay, cool. It is referring to the correct places. Yeah. Now I don't like this, that the after 1 the lowest rank I have is 8. It almost looks like I have the cost. So let me edit my table here. So especially in here, no, let me delete all of them. I'm going to create equals to rank this number only among these given costs. Freeze it, comma 1, I think it was. Okay. Okay, better, right? Okay, so let's try with the lowest cost. The lowest cost here is going from Y to C. Okay, going from Y to C. I want to allocate as many as possible here. Okay, let's see. I should bring this cost table as well in the view. Okay, yes, and I want to see my balance. Okay, so the lowest cost is $9 going from Y to C, so I'm going to allocate as much as possible. Supply is 50 maximum, so that is the best I can do. Now the moment I do this, the supply for Y is exhausted, so I'm going to color these 3 cells as, you know, I'm going to cross out these cells, let's say, basically. Then the next lowest cost, let me also cross this one, so then it's more obvious. The next lowest cost I can deal with is second one here, going from X to A. So let's try from X to A. How much is available? 100 is available, but demanded is 50, so I'm going to allocate 50 only. Now the moment I see 0 here, there is nothing more demanded, so I'm going to color all these cells as black. Okay, so then I know that I don't have to deal with this, with those cells. And I'm also going to color these here just to see. Out of these, I have the next lowest cost as going from X to C, which is $12. Yeah, if without these rankings, you can also do this directly from the table, as long as you keep coloring them, so then you do not get confused and you end up using the wrong cost. So at this point, we are talking about 18, 12, 18, and 14. These are the only costs we are comparing, and not any other. So as long as you compare, keep crossing out the right costs using this method, you should be okay. You do not need this ranking table. This is only for the sake of, let's say, tech savvy and easiness, okay, and be accurate. Okay, now the third one is this out of 18, 18, and 12 and 14, which is also reflected in here. 12 is the lowest cost. So which is going from X to C. So going from X to C, I'm going to allocate the leftover demand is 20. I have available of 50. So I'm going to allocate no more than 20 then. And I see 0 here. So I'm going to cross out these two cells. I'm going to cross out the cells here as well. Okay. So this 14 is not needed anymore. This 12 is not needed anymore. Now I'm dealing with 0. So this also needs to go. Okay. Now I'm dealing with this and this. So I have to satisfy the demand for B from either X or Z. So only 18 and 18. So there's a tie. You can choose any one of them. Let me go from the top one. So I have the demand of 80, but supply is only 30. So the best I can do is 30. The moment I do this, this is not a considerable cost anymore. At this point, without coloring, you're likely to choose 13. So but I've already colored this cell out, so I know that this need not be considered. So the only thing is going from Z to B. So going from Z to B, I have a balance of 50 as a demand, supply of 75. So I will send only 50 there. Nothing else is demanded. Then out of all these, in order to balance it, I can send the supply, the leftover supply of 25 from Z to a hypothetical place. Now in reality, this might be an issue because you remember there was a tie here of $18 and $18. Had you chosen the Z as a supplier first, so instead of choosing X as a supplier for B, had you chosen Z as B, you would have a leftover supply from X as a supplier, correct? So this might become at some point your ethical question as to whom do you choose when there's a tie, because somebody is being left with an unsold product on hand, because in this case supply exceeds the demand. Somebody has to deal with the surplus supply. Okay, now when we do this 50 times $10, 30 times $18, and 20 times $12, and so on, we come up with a cost of $2,630. Now this is just for the sake of example. This happens to be $40 less than the previous methodology of 2,670. Correct? Now again, so this was all about lowest cost. The next one is the linear programming. Now let's see if this methodology helps us do any better or different than the allocations we used using Northwest and lowest intuitive cost method. Okay. In this case, the only new thing I've done is I've also created the calculated LHS. Okay, calculated LHS, which is nothing but sum of the numbers we have allocated so far. Okay, that's all there is. Everything else being the same. The balance remaining is the same. Okay. Calculated LHS for demand and calculated LHS for supply. Okay. Reason I'm naming this is because this is how it's going to be named in the sensitivity report, if at all. So at this point, everything else being the same, my cost, total cost is the same. So everything, sum of the products for this table, control home, this table times the cost table. Okay, sorry, this much. Okay, everything else being the same. Now at this point, let's see where the solver is. Data, solver, and I'll say, oops, this is from the previous one. Set this as objective cell. I want this to be minimized by changing the cells in blue, okay, such that these calculated supplies have to equal the given supplies and the calculated demands have to equal the given demand. Okay, hit OK. This box has to be checked, simplex LP, and we solve. Now, oh, this is on different monitor. So this is the window you'll get to see. So no exclamation mark, everything was solved correctly. Just for the sake of information, I'll show you how to read the sensitivity report, but not usually required. But it does give you powerful information. So hit OK. Now, given this, you see, given all the three scenarios, there are multiple ways of meeting your demand from the suppliers. We could allocate 50, 50, 30, 20, and 50, or we could go 50, 30, 20, 50, and 50. Okay, in either of the cases, somebody was able to supply to somebody who wanted something. But in this case, this is the best possible way wherein you, as a business, the cost of sending the stuff to everybody, whoever demanded, was also minimized, right? So in this case, your profit margins are going to be up, such that the total cost of sending the material to everybody is lesser than either of the method that we use for the northwest corner and the lowest intuitive cost method. Now then the question arises, then why don't we use linear programming and the transportation matrix to solve all the time? Well, the thing is, you can make up the best plans, but the day you start at 7 in the morning or whenever the business starts, things can go chaotic. So in those cases, you can use some of the concepts from Northwest and lowest cost intuitive method to match the supply with the demand in shorter term. But on a longer term, you can keep your vision using linear programming, and that's how you can develop your strategies. So then on the long term, you're still minimizing your cost. In a short term, here and there, you are able to do whatever is required for the customer satisfaction and things like that. Now, let's look at the sensitivity report. Okay. The sensitivity report also tells you that there's a shadow price available of 12, 18, and 14 for the cells left hand side demand A, B, and C. Okay, so let's see. Left hand side demand A, B, and C. Okay, let me come back here. The cells are K47, L, and M47. K, L, and M47. Okay. Okay. So apparently these three cells are the most important. Why so? If you were to increase one more, if there was to be one more product demanded, the cost, the proxy for that in one more unit would be $12, $18, and $14. So if you had the chance, you should send one more product to B if you had the choice. Okay, because if you were to send one more unit to B, then you can make $18 more, or the cost goes up by $18 more. So you better be careful with this market. Okay, also it says that if you were to be able to supply from, this is 42, 3, and 4 in the column Q. In the column Q, 42, 3, and 4. Sorry, Q column, 42, 3, and 4. Okay, let's look at that again. So 2, 5, and 0. Okay, so 2, 5, and 0. So let me write that down. 2, 5, and 0. Now this is this was a negative, right? 2, 5, and 0. So if you were to look at reducing your cost, the first thing you should tell the supplier why to increase its capacity. That would cause $5 less in your overall product, in your overall transportation cost, right? So this type of information can be read from the sensitivity report, which is otherwise not available. If you were to make the same type of interpretation for any of these, it's just the loudest mouth wins. Yeah, there is no concept or logical reasoning behind it. In this case, you have a reason to give incentive to your supplier Y, such that you can send more from the supplier Y to any of the markets, A, B, and C. Okay, because you have a choice here. Should you get more from X or Y or Z? If and the sensitivity report says that if you were to get more product from Y, then you can reduce your objective function by $5. Okay, so I hope you guys find this interesting. Just remember, most of the people cannot do linear programming, and of the group who can do linear programming, most of them cannot interpret it. But that's where the biggest wealth is. Okay, so if you guys have any questions, feel free to contact me. Have fun. Take care. Bye.